Let's start with how to solve equations with binomial terms in the denominator. As of now, whatever sums we saw, there was only one term in the denominator, either x or y or 2x, monomial terms. Now what happens when there are binomial terms in the denominator, x plus y, x minus phi, something of that sort, right? Let's see. Let's start with the sum, exercise 3.6, sum number 1, sub question 4. Plus 1 upon y minus 2 is equal to 2, and 6 upon x minus 1 minus 3 upon y minus 2 is equal to 1. So as you all can see, there are binomial terms in the denominator, x minus 1, y minus 2. Are these equations linear? No, right? What is the basic difference? The difference is there are binomial terms in the denominator. How to solve this? Same, we will stick to our basics. Variables in the denominator, equations are not linear. Let's go for substituting. Now the question is, what are we supposed to substitute here? Let's see. What is the common denominator? X minus 1, x minus 1. X minus 1 is a common denominator in both the equations. So can we say 1 upon x minus 1 is a common term? So 1 upon x minus 1 is equal to p. Similarly, what is a common denominator? Y minus 2, y minus 2, right? As you all can see, y minus 2, y minus 2. Because y minus 2 is a common denominator, or 1 upon y minus 2 is a common term, we substitute 1 upon y minus 2 is equal to q. So first step remains the same, it's only after resubstitution things change a bit. Like in square root we saw we need to square both the sides. In normal sum we just cross multiply and we get the answer. Now let's see what happens here when we resubstitute, but that's later. First let's substitute. Let's substitute in the first equation. So phi upon x minus 1 will become 5p plus 1 upon y minus 2 will become 1q, that's q, is equal to 2. In the second, 6p minus 3q is equal to 1. Substituting is something which you must be very well aware of now, right? Let's now solve it by the method of substitution. In substitution method, first we number the equations as equation 1 and equation 2. Then we consider one of the two equations. Which one to be considered? Either of the two, whichever you find is simple. Let's consider equation number 1 here. That looks a bit simple as compared to the other, right? So 5p plus q is equal to 2. Let's solve it now. What do? We shift one of the variables to the other side so that we get something in the form of p is equal to something or q is equal to something, right? Let's do it. What do we get? 5p goes to the other side. We get q is equal to 2 minus 5p. We got q is equal to something. Don't forget this to number this as equation number 3. Name of the method? Substitution. What to do? Substitute something. What to substitute? Equation number 3. Where to substitute? The equation which was not considered. Which equation was not considered? Equation number 2. So let's substitute equation number 3 in equation number 2. So in equation 2, in the place of q, substitute 2 minus 5p. What do we get? 6p minus 3 into 2 minus 5p is equal to 1. Let's open the brackets now. 6p minus 3 into 2 is minus 6, and minus 3 into minus 5p is plus 15p. Take care of this sign, is equal to 1. Now like terms together, 15p, 6p will give you 21p. Minus 6 goes to the other side, you get 1 plus 6, 21p, 1 plus 6 is 7. If 21p is equal to 7, then p is equal to 3, right? No, don't do this mistake in the exam. Look carefully. 21p is equal to 7, then p is equal to 7 upon 21. 7 ones are, 7 threes are. So p is not 3, p is 1 upon 3. Many students do this mistake. 21p is 7, so p is equal to 3. No. 21p is 7, so p is equal to 1 upon 3. Once you get the value of p, is the sum over? No, we are still to find the value of q. To find the value of q, what do? Substitute p is equal to 1 upon 3. Where? either in first equation or second equation or third equation. But which is better in this method? Equation number 3. So let's do it. Substituting P is equal to 1 upon 3, in equation 3 we get Q is equal to 2 minus phi into 1 upon 3 in the place of P. Right? Now 3 is in the denominator, so we need to take the LCM. 2 3s are 6. What do we get? Q is equal to 6 minus phi the whole upon 3. What is 6 minus phi? 6 minus phi is 1. So here also you get Q is equal to 1 upon 3 and P is also equal to 1 upon 3. But is the sum over? No. Why? Because we are interested in the value of x and y, so we will have to resubstitute. What we should resubstitute here? We should resubstitute P is equal to 1 upon x minus 1. What's the value of P? 1 upon 3. So what should be the next step? 1 upon 3 is equal to 1 upon x minus 1. After resubstitution, what do? We cross multiply. So let's cross multiply. What do we get? X minus 1, 1 into 3 is 3. X minus 1 is equal to 3. Very simple to solve. X is equal to 3 plus 1. Therefore, x is equal to 4. You got the value of x. Is the sum over? No. We should find the value of y now. To find y, now we should resubstitute. Q is equal to 1 upon y minus 2. What's the value of Q we got? We got Q is equal to 1 upon 3. So let's resubstitute. What do we get? 1 upon 3 is equal to 1 upon y minus 2. Now cross multiply. We get y minus 2 is equal to 3. So we get y is equal to 3 plus 2. We get y is equal to 5. So the answer is x is equal to 4 and y is equal to 5. As simple as that. So one thing you all must have realized that all the sums are similar. The only changes, those minor changes that happen in the calculation after resubstitution. Everything else remains the same otherwise.